We're going to talk about why GEISA. I'll give you a technical overview of what GEISA is, and then a project overview, just the status of the project, and then hopefully we'll have time to do a little bit of Q&A. Before I get going, though, give me a sense of who is in the room. How many of you are from TSOs, DSOs, utilities? Okay. And how many folks are from different types of vendors? And how many of you program? Okay, so we've got a decent complement of geeks in the room. That's a good thing. That helps me target what I'm talking about. So I'm Michael Garrison Stuber. I work with Southern California Edison as a solutions architect. I've been doing Linux systems since 1995 and have been doing things in the utility industry since 1997. In terms of GEISA, as I mentioned, GEISA is the Grid Edge Interoperability and Security Alliance. And basically, GEISA is a project that is designed to address interoperability at the edge of the grid. By that, I'm specifically meaning electric meters, but I'm meaning more than electric meters. Electric meters is an initial place that we're starting, but we're also interested in being able to use GEISA on other types of distribution automation devices. So cap bank controllers, load tap changers, things like that. We have a formal mission statement enabling secure interoperability at the grid edge to accelerate adoption of advanced analytics. And really what we're talking about here is ensuring that as utilities purchase devices from different vendors, that they can run applications on those devices that they source from anywhere, and that utilities aren't locked into devices that come from a singular vendor. So one of the challenges when we talk about grid edge is edge can mean different things to different people. So I do want to emphasize from a grid edge standpoint, we're really talking about devices in the distribution network. We are not talking about secondary substations. There's a lovely project, E4S, that is addressing secondary substations. We're also not talking about substations. If you want to do cool things in substations with virtualizations, check out CPath. And we're not talking about Internet of Things. We're not talking about smart devices, data center, general IT edge. There's the whole LF Edge effort addressing that, and they're doing all sorts of cool stuff as well. We're very narrowly focused on the grid edge. I also want to provide a little bit of background. I am from the US. In the US, meters are round, they're on the outside of the house, they go in sockets. So there are some interesting differences here that are worth noting, because some of the assumptions that GEISA is operating under are a bit US-centric right now. We do have participation from time to time from folks in the EU, and one of the reasons I'm here is we'd love to have more participation from folks in the EU. But I will admit, in our technical conversations, we're often thinking about the left-hand side rather than the right-hand side. The other reason that I call this up is with an internal meter that has an output port, it's really easy to add external edge compute, because that can just be a separate module that you plug into that output port. And if you want to change that a year down the road, 10 years down the road at any point, you can ship the new module to a customer, ask them to install it, and away you go. In the US, when we have these exterior meters with this plastic cover on it, there's no good way of swapping out the edge compute. So if we have edge compute running in the meter, we live with it for the lifespan of the meter, which is typically about 20 years, with a system service lifetime usually about 25 years. So with that as a level set, let's get into why GEISA. Many folks in the room are already aware of this, but the fundamental reason that GEISA is necessary is because the nature of the grid is changing. We are moving from spinning mass generators to more and more renewable assets. And with those additional renewable assets, we lose inertia in the grid. I was having a conversation with someone last night. They were mentioning that the transmission organization that they're part of was actually looking at putting in large spinning mass assets to make up for the lack of spinning generators because of the penetration of renewables, and he was suggesting that a lot could be done with distributed batteries. Well, this is the sort of thing that GEISA can help solve, because we have electric meters all over our service territory. If we can run applications in those electric meters that can interact with distributed batteries, we can start addressing some of the inertia issues. We can start addressing certain aspects of electrification, of control, being able to use the distribution network more effectively. It's worth noting that the nature of smart meters generally is changing. And I want to be clear here, I'm talking about AMI meters, not AMR meters, okay? So today's, generation 1 AMI meters, they were able to do interval data. They typically had an embedded microkernel with hundreds of K worth of RAM, maybe one processor, maybe two, and they typically ran a single image. What we're seeing is a next generation of smart meters, and this next generation of smart meters is able to do 1-second data, it's able to do waveform data, it has gigabytes of storage, it is capable of running genuine rich operating systems like Linux. Typically it'll have multiple processors. These aren't the AMI meters that utilities initially rolled out, but it's worth noting that the AMI meters that utilities initially rolled out, many of them are coming up to the end of their service life. In the US, a recent EPRI report shows that about 60% of US utilities are going to be replacing their AMI meters in the next 5 years. The map over here I pulled from a report on distribution grids in Europe. This is from 5 years ago, talking about AMI deployments in Europe. The dark blue countries are ones that are widely deployed in terms of AMI. Those devices have a lifetime. They're going to come out. They're going to be replaced. What does the next generation meter look like? Well, it's going to have edge compute. And the goal of GEISA is really to ensure that that edge compute is interoperable across different vendors. So the role of the meter is changing as well. If we think about what the electric meter can do, it used to simply be the cash register. That was it. Then potentially we added disconnect switches to it, a little bit of control capability. We added interval data to it where we could have more visibility, and it was a poor grid sensor, but sort of a grid sensor. These days, it can truly be a grid sensor. It can also be a communications hub, and it can be a consumer enabler. The picture here, this is a waveform capture of a capacitor bank switching event. And you can see the degradation in the waveform when the capacitor bank switches in and out. Your modern next generation AMI2 meter is capable of recording that waveform data, is capable of sensing different disturbances on the grid. And that information can be used to locate and characterize issues. That information can also be used to locate issues within the home, safety issues, loose neutrals, and it can be used to help consumers understand what they're doing with their energy usage. So 1-second data and waveform data can be used to understand when a customer is starting an EV charging session, or when their refrigerator is cycling on and off. So there's a lot of things that we can do with a modern smart meter. So what does GEISA do for us from a benefit standpoint? Fundamentally, it solves 4 problems. First of all, it addresses issues of supply chain security. Many utilities found out during the pandemic, if they had been getting devices from a single vendor, that vendor couldn't keep up with demand. They had issues in their supply chain. They were unable to deliver product. But we also see this with trade wars and tariffs and other things that are disrupting global supply chains, that it's not enough to have a great vendor that provides a great product and single sourcing it. Utilities really need diversity of supply. If we have interoperability in these edge environments at the meter, we're able to purchase devices from different vendors and still be able to run the same apps on them. GEISA is also about unlocking innovation. One of the challenges that happens with many smart meter systems right now, currently all of these edge environments are proprietary to the vendor. They often use the same technology, but if you go ahead and get a system from, say, Landis & Gyr, you can get apps for that LNG system, you can't take those apps and simply run them on an Itron meter or run them on an EDMI or a Sagemcom meter. If we have an environment that's open, it creates a situation where vendors that are interested in generating apps for smart meters generally are able to go ahead and create and market those apps and not be stuck targeting one specific vendor. They're not stuck where, hey, they invested the engineering dollars they had and went after vendor X, and then they go to utility ABC, and that utility has bought meters from a different vendor, and therefore they can't make a sale. We also see GEISA addressing future-proofing. One of the challenges in this space is that while there is some excellent innovation, we can have vendors change their strategies as to what they're deploying, going ahead and purchasing competitors, rationalizing product lines, making those sort of shifts that they need to in their business to stay profitable, but that can lead to devices that are abandoned because they're no longer part of that vendor's strategy. Having an open interoperable environment ensures that utilities aren't stuck as vendors change strategies. And then finally, there's a benefit of efficiency that we can get out of standardizing these edge environments. As we have a common baseline, if we think about what's happened in the IT space, more and more things run on top of Linux because it provides that base foundation that I don't need to spend time investing in the operating system itself, the file systems, all of the infrastructure. I can focus on my application. And as we have a common operating environment for the meter, that puts vendors in a position where they don't have to invest as much in doing these basic blocking and tackling items. They can just rely on a well-defined platform and build innovations on top. So the last comment I'll make here in terms of why GEISA, utilities have worked on interoperability before. The pictures here are some early light bulbs. Once upon a time, light bulbs were not compatible with each other, and you had to get light bulbs for your lamp from a specific vendor. Like this was the way it was. These days, you could just go to the store and buy a light bulb, and it will work in your lamp. Interoperability happens when it makes sense. And I think we're at the point when it comes to grid edge computing where we're seeing innovation from vendors, we're seeing some designs, but we're also seeing commonality between them, and giving the vendor community that nudge, defining a specification that enables interoperability across these devices is something that we can and should do. So with that, I'm going to switch to the technical overview. So GEISA really tries to address three things. It tries to address the management API, a data API, and an execution environment. If we take a look at our diagram here, this orange dotted box says platform implementation. You can think about this as an electric meter. You can think about this as a DA device like a cap bank controller that you want to be able to run edge applications in. And what we're trying to do with GEISA is we're trying to specify an API that gives you access to the functionality of the device, the sensor data, the actuator controls. We're trying to define an execution environment that ensures that you have consistent access to things. If you've spent a lot of time doing Linux system administration, you know that there's little differences between Linux systems. If you're running, say, a Red Hat system versus a Debian system versus an Alpine system. And if you're trying to deploy an app on those environments, you have to deal with those differences. Well, we're trying to make sure that there's a consistent environment so that we don't have to deal with those differences when we're trying to deploy an app onto a meter. And then when it comes to being able to deploy these apps, so I have a consistent environment, I have a consistent API, great, I can roll an app out to my meters, but can I? If I don't have a consistent management mechanism to push those apps down to the devices, I may have uniform environments, but I can't go ahead and take advantage of that, or as a utility, I potentially have to have multiple head-end systems to manage these fleets of devices. And so in the GEISA space, we've addressed the API, the application and device management, and then the execution environment. And you'll note that I have two execution environments. When we started this project, we had one. It was exclusively Linux. And in working with the vendor community, there's also an interest on the part of the vendors to have a virtual execution environment. And there was a lot of discussion as to whether apps could be written against both Linux and the virtual execution environment. And we realized that there was really no good way of having apps that could run on both. There were just some fundamental differences. And rather than rejecting the virtual environment entirely, we decided to create a definition for Linux and a definition for the virtual environments, because there are vendors doing both, there are utilities buying both, and we'll see where the market goes, but it seemed worthwhile to define both. So in general, in terms of the GEISA effort, we're focused on selection over invention. Most of what we want to do here is not create anything new. We're trying to specify, if you use this series of things in this way, you'll have interoperability. We don't need to create new protocols. There are plenty of them out there. What we do need to do is say, we're all going to play by this same set of rules. And so we're trying to define that same set of rules in our specification. I've talked some about the application and device management environment. For this, it's really focused on addressing that head-end management problem so that I can have a consistent management system. And so we're defining what the interface to the devices is. We're also defining what the interface from a management system is. And a platform vendor, if they wanted to create devices and not bother with a management system, they could go ahead and just create those devices. And if a software vendor wanted to create a management system that would run on any device, they can go ahead and do that as well. Certainly, some vendors will choose to offer both, but a good definition here allows those things to be independent. In terms of the technologies that we're using, we're dominantly using lightweight M2M transactions to facilitate the application and device management. We are expecting to do that over UDP and CoAP. and we're using DTLS for security. Up at our management system, the data that is coming back from the system or the commands that are being pushed down to the system will be exposed through a REST API over HTTPS. Looking at the API, the API is to provide that consistent interface to things like the disconnect switch, waveform data, billing data, instantaneous data, as we go past the meter into other types of devices, whatever the actuators and sensors are. In terms of the technologies that we're using there, we're actually using MQTT as an internal bus. We do not expose that externally, but it has some advantages in terms of a clean publish and subscribe API. It's a message-based API. We're using protocol buffers for how we're exchanging the actual data. Specifically for waveform, we're using Unix sockets because when we talk about waveform data, it's a lot of data when we're doing 16 or 32 kilohertz sampling and we're trying to push data every 200 nanoseconds. We needed something that was just going to be fast. And we have a series of messages that we know we need to define. The ones in bold are ones that we have initial definitions of. The ones not in bold we haven't gotten to yet, but this is very much a work in progress. Our Linux execution environment is really focused on this write once, deploy anywhere. And our virtual execution environment is trying to do the same thing, but taking advantage of a virtual machine. Think along the lines of a JVM when you think about the virtual execution environment. That's really the type of technology we're talking about. I'm gonna skip a couple slides here and get to our status. So we have active participation from a whole bunch of platform vendors that are involved in creating AMI 2.0 or next wave AMI devices. We have a draft specification that's under development. So the 0.15 version is posted on our GitHub page as well as on our Confluence page. And we also have an initial conformance test framework. We've been working with the guys at Savoir-Faire Linux to put that together because for this to really be practical, we need a specification that people can follow and an ability to run a program and see whether that implementation follows the specification. We have our fourth face-to-face for 2025 planned for October. So we've got a decent amount of momentum, and we're trying to do demos at Distributech in 2026 in San Diego. If you're interested in getting involved, we welcome any and all participation. So you can find us on the LF Energy webpage. If you go to the LF Energy project page for GEISA and then click on the Get Started button, or alternatively just click on the Wiki button, there's a page for onboarding that has information about the mailing list and the Slack channel and the meetings and whatnot. And in terms of our overall process, we are very much focused on a consensus-based approach, and much of our technical decision-making has been driven around people putting together sample code about different things. So, as we were debating whether or not to use message pack versus protobuf, we had folks just go write some code to look at what was going to give us the better performance at the least hassle. Similarly, as we've been looking how we want to do application isolation, we're using container technology inside of the Linux execution environment. But we realized we didn't necessarily have to specify exactly what the container technology was as long as it met certain requirements. And so we've been working through each of these things with trial efforts to inform our decision making. And we meet the first and third Tuesdays at 8 a.m. Pacific, 5 p.m. Central European Time, or 11 if you're on the East Coast of the US. I am basically out of time, I think, but I would be happy to solicit a question or two if anyone has one that I can answer quickly.
I have one question on the file. What is the horizon for having a reference implementation?
Um,
Because you mentioned demo, but you also mentioned
Yep. So the question was, when do we expect to have a reference implementation? And the basic answer is we're not at this stage planning on doing a full reference implementation, but we do have multiple platform vendors that are committed to providing implementations. We will have, as part of the conformance test, a dummy reference implementation. So, to have the conformance test, you have to test the test, so you have to have something to test. As the SFL Linux guys have been building out the conformance test pieces, they have been writing things to test, but that reference implementation isn't, for example, going to be wired into any sensors or actuators or things like that. So it's not a full reference implementation like you get with something like CPath. And with that, I should probably hand over the microphone and the stage. But thank you. I appreciate you coming. I am happy to answer any questions afterwards. Please feel free to hunt me down. I'll be here the rest of the day and tomorrow as well.